Hello, today I will begin with a geomagnetic storm which was caused by a CME impact on November 10. According to NOAA, the KP index reached 5 points around the noon. However, readings from POES satellites show something different. According to them, auroral power reached its highest value of 128 gigawatts just before 3 UTC. And now the most important information. During the entire storm, the BZ component of IMF remained positive. This is against known rules of space weather interactions. If we look at the ACE solar wind data, which is being used in SWMF simulations, we'll notice easily that the BZ turned south around the midnight, and it didn't cause the auroral power to grow. Around 1st UTC, BZ became positive. At the time when POES recorded the strongest outburst of auroras, it reached 20 nanoteslas. There was a sudden drop in the value of BZ component to minus 7 nanoteslas. But the time doesn't match with POES readings. To make it more funny, let's add the fact that around 3 UTC the density of solar wind was seriously decreased. But let's look at the SWMF Magnetosphere simulation. This is the moment of aurora outburst. As you can see, there is nothing normal in the response of magnetosphere. Okay, this was just a warm-up. Now something more difficult. Geomagnetic field and its response for the CME impact. First couple words about the subject. Geomagnetic storms, which are caused by CMEs, should affect the readings over entire planet, and the disturbances supposed to be stronger at higher latitudes. Geomagnetic pulse, which caused the strongest auroras, was recorded only at mid-latitudes, and doesn't look scary at all. At least in Canada. In Europe it was much stronger. Anyway, it was detected on both continents, so I can call it global. In the difference to the rest of geomagnetic activity, which took place during the rest of the day. For example, in Northern America, the strongest disturbance was recorded around 12 UTC. Sorry, more like 11 UTC. In Mianuk, the jolt reached more than 500 nanoteslas. At the same time, in Europe, we can see only some minor disturbances at higher latitudes. Much stronger pulse, which took place couple hours later, wasn't noticed in Canada. Canadian disturbance can be explained with this sudden drop in magnitude of IMF BZ component. And this is the reason why NOAA raised the KP index to 5. Of course, don't forget that impulse took place 1 hour earlier. Third impulse, which was recorded on both continents, was probably caused by this shift of IMF polarity. BZ dropped almost to minus 10 nanoteslas. This is enough to trigger a geomagnetic storm. However, in Canada, the disturbances were much weaker than the first jolt. But let's leave for a second the CME impact and take a look at the behavior of ionospheric electrons. Last time I pointed out that the cloud starts to gain vertical orientation. It seems that the process is getting stronger. Cloud is stretching itself towards the poles and increases the density over high latitudes, especially in Europe and Northern America. Just look here. Of course, it can be just another coincidence, but since the electrons started to reach even to Canada, earthquakes started to appear in very uncommon locations. Talking about changes of the geomagnetic field. Some of those changes are frequent and depend on the orbital cycle of Earth, like the variable polar cap potential, which seems to be stronger over southern or northern hemisphere depending on the position of Earth in space. Or to be more concrete, depending on the angle of geomagnetic dipole tilt towards the ecliptic plane. Those frequent shifts affect all energetic particles in ionosphere, and that's why some of them, like nitrogen oxide, gather over northern or southern pole in different months. Right now the density is visibly increased over southern polar cap, but 2 months ago the situation was opposite. But much more important are the changes which are taking place for the first time since those monitors were made. As the example, I will use the atomic oxygen monitor. Bottom image shows its concentration in November 2012. The one above shows the current situation. Those who started to watch my movies some time ago remember probably that those particles remain over the equatorial belt most of the time. However, during geomagnetic activity, particles might behave irrational. Just like 2 years ago, on November 13, 2012. Those disturbances were probably caused by increased Kp index, but the most current animation is different. During last couple days, the geomagnetic activity was very low, and yet the behavior of atomic oxygen is very odd. Just compare those images. There is no significant drop of density on the night side, what was being recorded in last 2 years. Instead, the dark blue hole appeared over southern pole, what caused the main density to shift to the north. This is something absolutely new for me, and I'm afraid that I know the cause. But first, let's check other monitors. This monitor shows the ratio of oxygen and nitrogen. I didn't record this monitor never before, but some things are clear for me. Upper monitors show the readings from 13th of November 2012 and 2013. Bottom one shows the latest ones. You don't need to be a genius to notice the differences. And to make it clear, current situation doesn't look to be temporal. I don't think that you will be surprised if I tell that those changes are caused, in my opinion, by the shift of geomagnetic field. This is the last working simulation of ionospheric convection which I know. Colors represent the strength of electric charge, so it's rather easy to read. Notice that the positive potential seems to be equal over the polar cap and at lower latitudes. Weird? For sure, but I was expecting it for some time, as it is the sign that the magnetic polarity is about to make a 90-degree tilt. But let's leave for now all those space weather monitors and talk about a possible effect on the environment which affects us directly. I mean the air currents in atmosphere. Arrows show more or less how the air masses supposed to circulate around the globe. Over the equator, clouds are normally moving clockwise. That means against the planet rotation. Over the hemispheres, air currents look like a sinusoid, and their direction is opposite to the equatorial belt. And this is how it's supposed to look like over the northern polar cap. Anyway, if you ask the specialists what is the reason of such shape of the currents, you will hear about seasons, planet rotation or the placement of continents. I don't know if anyone would tell about the geomagnetic field. Of course, besides me. After asking Uncle Google, I can tell you that some people thought about it already. But it's not that easy to find some resources. Anyway, I'm telling you about this stuff for a reason. It's just my private guess, but I think that during the pole shift, the main polar cap air currents will go through a change as well. If there would be a complete 180 degrees flip, direction of the circulation would be opposite. If the northern pole would shift to the equator, polar vortex would follow it as well. And now, look just for a while at current situation. Okay, time to deal with more serious stuff. Some of you started probably to wonder if I didn't forget about my new favorite toy. This bird. Of course I didn't. And now I will use it to show you how dynamic the geomagnetic field can be. Sadly, online solar wind data is not updated since October, but I can still use satellite readings. Here you can see the data recorded by GeoTail satellite beginning from October 25 till November 12. Thick and colorful arrows represent vectors and strength of local magnetic field. Thinner ones show velocity of plasma, while their colors show the density. During the time, GeoTail made 3 full orbital cycles. Those readings were recorded during the first one. Green vectors mean that the strength of geomagnetic field was rather low. Here you can see how the orientation of magnetic field make a shift when the satellite is passing through the magnetopause. And here density of plasma grows when the craft passes through the bow shock. Another thing which is worth to notice is the direction of plasma velocity, which is clearly different than dimension x. During the second orbit, strength of magnetic field grew quite a lot. besides velocity vectors became parallel to x-dimensional axis. But notice what is the orientation of magnetic field within the magnetotail. Field lines are directed towards the planet. It's important because if we look at the readings recorded during next geotail orbit, we'll notice that the direction makes a sudden flip when the craft enters the inner parts of magnetosphere. The strength of a geomagnetic field dropped again, and the vectors are now yellow and orange, not red. Besides, the plasma started to flow in at an angle once more. But most important is the orientation of the local magnetic field within the inner magnetosphere. This is how it looked like during the third orbital cycle of the satellite. And this is how it looked before. Vectors started to point out in different direction. Here we can see the directions of plasma flow recorded by geotail satellite. Green color shows the Y dimension, east-west, while blue one the Z component, north-south flow. Here we can see the variations of geomagnetic field magnitude recorded by Timmy's aircraft. But let's go back to the ground, where not so long ago magnetometers recorded rather strong disturbances. In Kiruna they reached almost 700 nanoteslas. Around 3 UTC on November 16, the K-index reached their 7 points, what means a strong geomagnetic storm. But the strongest auroral outburst was recorded by POES satellites couple hours later, just before 9 UTC, when auroral power reached 156 gigawatts. Geomagnetic impulse which was connected with this event was recorded mostly in Canada. In Europe, the magnetometers remained calm at this time. Despite the strength of local disturbances, NOAA raised the KP index only to 4. In my opinion, it is too low. Anyway, this is the cause of this entire mess. Impact of a coronal hole stream, through almost to 700 km per second. But the IMF orientation remained very unstable during the impact, and BZ component didn't turn south for long enough to explain such strong disturbances. Those are the readings from Bartol's cosmic ray page, before they edited the size of those dots. Sadly, I forgot to save the second graph, which shows the directions of cosmic rays, so I won't show you what was the difference between them. Anyway, as I said many times before, each time when we see a clear dipolarity, we can guess that we are dealing with magnetic connections. I've recorded many attacks of the dots on those graphs, and most of the time blue and red circles appeared next to each other and they had opposite directions. Observations of those angles allowed me to guess the distance from Earth to the low energy field source. This time opposite dots had a huge gap between them, with a concentration of smaller rays in the middle of it. I think that while Earth gets further from the low energy field source, it starts to be affected only by one of its magnetic poles. And because the positive pole of Sun, which allows the low energy field to make a connection, is facing us right now, it is possible that we just went through a stretched flux tube, which was much bigger than previous ones. From other odd space weather activity, it is worth to mention the strange bursts of high-energy electrons, which took place on 14th of November, and which powered the radiation belts with a big dose of energy. Here we can see a sudden inflow of electrons at 1 MeV energy band. It seems that between the bursts of high-energy particles, Earth experienced some backside gusts of neutral particles. It seems that the currents of particles at higher altitudes are becoming vertical. Look at the shape of the electron cloud in the ionosphere. It reaches even to New Zealand, where just by coincidence a strong 6.6 magnitude earthquake took place 2 hours ago. Right at the time when a closed magnetospheric field line had a reconnection and became an open one, connected to the South Pole. Even more important is the shape of the jet stream, which starts to be vertical as well. This is causing an opposite flow of Arctic air masses to the south, what is cooling down big part of Northern America. The entire air circulation over Northern Hemisphere is seriously screwed up already. Instead of single polar vortex, there are two separate ones, which are placed on opposite sides of hemisphere. If it won't change soon, things might get rough quite fast. And with this optimistic accent, I'll finish this episode. Class dismissed. Be safe. Peace.